Air conditioning hasn't been around for that long. In fact, Jim Carrier invented the very first air conditioning unit back in 1902. Now that unit, by today's standards, was extremely large and cumbersome and not very efficient, but it was the start of something that people that didn't live in the Arctic had long desired and represented one of the greatest achievements in human comfort ever. First, a reminder. The most important lesson you will ever learn is always put safety first. Whether you're just starting out or have years of practice behind you, safe work habits should be your top priority. This program will summarize the operation of residential cooling or air conditioning systems. You'll learn how each of the major components in these systems function. By understanding the refrigeration cycle and the purpose of major parts, you'll be better prepared to work and succeed in one of the many jobs related to refrigeration and air conditioning. Air conditioning can be defined as a process that heats, cools, cleans, and circulates air while controlling humidity or the moisture content of the air. This program will focus on the mechanisms for cooling and dehumidifying the air in residential applications. The two major assemblies of a typical residential air conditioning system are the condensing unit and the air handler. The condensing unit contains the compressor that pumps the refrigerant through the system, and the condenser that transfers heat extracted from the home or conditioned space to the atmosphere or outdoors. The air handler contains an evaporator that collects hot air from the home and a device for metering the refrigerant into the evaporator. To fully grasp how everything works, first, you have to understand a few basic laws of physics. Matter exists in three states: solid, gas, and liquid. Water is a perfect example of all three states. It is a liquid at room temperature. When heated above 212 degrees Fahrenheit, it becomes a gas, and it becomes a solid, ice, when cooled below 32 degrees Fahrenheit. When a gas condenses into a liquid, heat is released to surrounding objects. However, when the liquid vaporizes into a gas, heat is absorbed. Cold is simply the absence of heat. This is important to a refrigeration or air conditioning system because the refrigerant is forced to change from a liquid into a gas and then back from a gas to a liquid. This makes the system absorb heat during vaporization to produce cooling and then release heat during condensation. Since the vaporization process occurs inside the home, it collects or absorbs heat from the inside air. And since the system transports refrigerant outside the home for condensation, this heat is released to cause a cooling effect inside the residence. Three methods of heat transfer are conduction, convection, and radiation. Conduction is heat transfer when objects are touching or in contact. The heat is transferred directly from the hotter object to the cooler object. Convection is heat transfer through the air between two objects. The objects are not touching, and the air is the medium of heat transfer. Radiation is heat transfer caused by infrared rays from the sun or from any warmer object radiating its heat to a cooler object. The BTU, or British Thermal Unit, is a measurement of the amount of energy needed to raise the temperature of 1 pound of water 1 degree Fahrenheit. A refrigerant, like this 134A, is a substance used in a cooling system to absorb heat during evaporation. Although many chemicals, such as R22 and R12, have been used in the past to facilitate refrigeration, most have been found to adversely affect the environment and cause long-term problems, such as global warming. Today's refrigerants are much safer, and manufacturers are continually looking for new blends that will be even safer without compromising the safety of technicians or the comfort of those using the air conditioning unit. The worst enemy that an air conditioning system has is moisture. Air and water will not only cause an air conditioning system to run less efficiently by taking up space in the lines and preventing the proper flow of refrigerant, but water will also cause physical damage to the components of the system. To fill or recharge the system, air and moisture must be evacuated out, and then the correct amount of refrigerant and oil must be metered into the low side of the system. Refrigerant oil is added to the refrigerant to lubricate the compressor. A cooling or refrigerant system is commonly divided into two sections, the high side and the low side. The high side includes all of the parts that operate at high pressure. This includes the compressor, the condenser, receiver, the metering device, and the high pressure lines that connect these parts. The low side includes the parts after the metering device. This would include the evaporator and the larger low pressure lines. This animation reviews the basic refrigeration cycle and shows what happens to the refrigerant as it is pumped through each major component. The compressor moves refrigerant through the system. It compresses the refrigerant and pumps it as a high-pressure, high-temperature gas to the condenser. The condenser allows heat to transfer out of the refrigerant and into the outside air flowing through the condenser. This removes heat from the refrigerant and causes it to condense into a liquid state. The cooled, high-pressure liquid then flows through the liquid line to the flow control device or orifice restriction. When the liquid refrigerant finally passes through the restriction, it expands and its pressure rapidly drops. The refrigerant then boils and changes from a liquid to a gas. This evaporation causes the temperature to drop about 40 degrees Fahrenheit at the evaporator. Low-pressure vapor and a small amount of liquid refrigerant then flow into an accumulator that prevents the liquid from entering and damaging the compressor. Low-pressure vapor is again pulled into the compressor and forced to the condenser. This cycle is constantly repeated to produce a strong cooling effect at the evaporator. The condensing unit mounts outside of the home, usually on a concrete pad. It contains the condenser coil, compressor, fan, accumulator, and other parts enclosed in the metal housing. The compressor is the heart of a cooling or AC system because it pumps the heat-laden refrigerant through the system. It reduces the pressure on the low side and increases pressure on the high side. A residential compressor is a hermetically sealed unit, which means the system is totally enclosed. The compressor's electric drive motor and pumping mechanism are sealed in the system. The compressor is normally installed on rubber mounts to reduce noise and vibration. A fiberglass blanket can also be wrapped around the compressor to reduce noise even further. An electric crankcase heater is often installed in the compressor to warm the oil and refrigerant and keep the system ready for operation. The compressor's electric motor is usually a 240-volt high-efficiency design. The armature, when electrically energized, is forced to spin by the magnetic forces acting between the stationary windings and the armature windings. Various types of compressors are used in residential air conditioning systems. The newest and most common is the scroll compressor. It uses a rotary motion of small, curved blades to pump the refrigerant. One set of blades are stationary and the others are rotated by the compressor motor. The resulting action compresses the refrigerant vapor and moves it through the system. Reciprocating or piston compressors are an older technology but are still available. The drive motor rotates a crankshaft, which moves a piston back and forth to produce a pumping action similar to an ordinary air compressor. Reed valves are one-way flow control valves used to keep the refrigerant moving in the correct direction. They have a thin steel membrane that can flex open or closed with pressure changes. The condenser is an air-cooled heat exchanger. It dissipates the heat from the refrigerant. It receives hot gas from the compressor and transfers much of the heat out into air passing through the condenser coils and fins. As a result, heat is carried away from the interior of the home. The condenser coil is a series of tubes routed inside closely spaced condenser fins. The hot gas line from the compressor feeds hot refrigerant vapor into the condenser coil. The fins increase the surface area of the condenser for more efficient heat transfer. The fins assist by absorbing the heat from the tubes. As the condenser cools the hot vapors, they change back into a liquid state and are ready for another cooling cycle. The condenser is usually raised off the bottom of the unit's pan to avoid corrosion. Drain holes in the pan allow water to drain off. A condenser fan pulls air through the condenser. The fan can be mounted horizontally or vertically, depending upon condenser design. A motor spins the fan whenever the compressor is running. Air conditioning lines carry the refrigerant to the components of the air conditioning system. The tubing is usually made of copper or aluminum, but steel and stainless may also be used. The suction line is the larger diameter low-pressure line between the evaporator and compressor. It carries heat-laden refrigerant away from the evaporator. The low side of the system is normally insulated to keep it from absorbing heat and sweating moisture or water. The liquid line is the thinner high-pressure line, which carries cooled high-pressure liquid refrigerant from the condenser to the flow control device. Service valves and fittings are often located in the lines so you can check, remove, and add refrigerant. Safety caps screw over the service valves to keep out debris and prevent damage. Schrader-type valves contain a spring-loaded valve that only opens when a small center pin in the valve is depressed. This is similar to a valve in a bicycle or car tire. Backseat-type service valves can be turned to isolate sections of the system so that the refrigerant is not lost during service. The accumulator is a storage tank in the suction line going to the compressor. Small quantities of liquid refrigerant collect and boil away in the accumulator to prevent any liquid refrigerant from entering and possibly damaging the compressor. A contaminant is defined as any foreign substance that could cause damage to the system. Now, this could include water, acid, dirt, or other particles. Filter dryers are used in the lines to trap and hold contaminants so that they cannot enter and damage components like the compressor. They are usually located in the liquid line. A desiccant is a substance with microscopic particles used to absorb moisture in the system. Located in the filter dryer, it helps to protect the system from internal corrosion due to moisture contamination. A sight glass is sometimes provided so you can visually check the refrigerant in the system. It aids in troubleshooting. Excess bubbles might mean air in the system. For example, a cloudy sight glass might mean deteriorated desiccant. Oil streaks can mean low refrigerant. And a clear sight glass could indicate a completely full or completely empty system. Remember that a sight glass should only be used as a guide. If you encounter one of these conditions, it should help point you to the correct conclusion. Now, as you continue your studies, you're going to learn many techniques that you can use in the proper diagnosis of air conditioning troubles. The evaporator, like the condenser, is a large volume heat exchanger with coils and fins. It absorbs heat from the air in the home and transfers it into the refrigerant. The evaporator with central air conditioning is mounted above the furnace. When refrigerant enters the evaporator, it is about 85% liquid and 15% vapor. As the refrigerant moves through, it boils, and more of it turns into a vapor to absorb heat. The two most common methods for metering refrigerant into the evaporator are the fixed bore metering device, such as this capillary tube, and the expansion valve. Now, these are the dividing point between the high and low pressure sides of the system. A fixed orifice metering device is a precisely sized orifice or opening for regulating or metering refrigerant. It is a small tube, often wrapped into a coil. Refrigerant pressure entering the capillary tube is high. Once the refrigerant flows through the orifice, its pressure drops. As a result, the temperature of the refrigerant changes from about 110 degrees Fahrenheit to 40 degrees Fahrenheit, giving off a cooling effect. An expansion valve is sometimes used for more precise control of refrigerant flow and evaporator temperature. A sensing bulb is used to detect temperature and operate the expansion valve. The bulb is normally attached to the line leaving the evaporator. As the bulb becomes cooler, pressure in the bulb, bulb line, and valve diaphragm decreases. The air handler, consisting of a blower and its housing, circulates the return air through the evaporator ducts in the home. The fan or blower pushes the return air through the evaporator tubes and fins. The cooling air is then forced through the ducts, going to various rooms in the residence. One important feature of all central air conditioning systems that you should know about is that they all have an electrical safety disconnect located outside the home. As required by electrical code, its purpose is to cut power to the condenser unit when servicing or making repairs. It is a safety requirement that is used to help prevent electrocution. The electrical controls in residential cooling systems vary. However, you should understand the most common types of electrical controls used in a typical system. Control circuits commonly operate on 24-volt alternating current from a step-down transformer. The step-down transformer feeds out control voltage and current to the other control components. When the thermostat calls for cooling, it closes, sending current to the starter contactor coil. When the contactor closes, it sends 240 volts to the compressor and condenser fan. The thermostat turns the air conditioning system on and off in response to changes in room temperature. The pressure switch is used to shut the system down when refrigerant pressure becomes too high or too low. For example, if refrigerant has leaked out, the pressure switch will keep the compressor motor from running and being damaged from lack of oil circulation. A heat pump is used for both heating and cooling. A reversible cooling system, it has valves that reroute the refrigerant so that the evaporator becomes the condenser and the condenser becomes the evaporator. In the cooling mode, the heat pump acts as a conventional air conditioning system, with the evaporator pulling heat out of the residence. However, when switched to heating mode, the condenser outside the home becomes the evaporator to absorb heat from the outside air, and the evaporator becomes the condenser to release heat into the home. The building automation system is a high-tech network of computers and devices that will control the HVAC equipment to maintain proper building conditions. Today, when a building has a problem, an alarm is immediately sent to the Intelligent Service Center. Often, the problem can be fixed before anyone in the building knew anything was wrong, and without a technician physically going to the site. The technology of the control system can be used to predict problems long before they happen, which in turn allows for simple adjustments to be made that will prevent a costly failure in the future. You should now have a better understanding of the construction and operation of residential air conditioning systems. As you continue with your studies, you're going to get more and more detailed information about each of these system components, along with design, installation, diagnostic, and repair techniques.